Did you know that deep beneath our feet, the Earth's inner core, an iron sphere as hot as the sun, moves independently from the rest of the planet? Scientists have debated its rotation for decades, and new research suggests that the core's motion has slowed down dramatically. But what does this mean for us? Could it affect the length of our days, the planet's magnetic field, or even future earthquakes? Let's dive into this fascinating discovery and explore its potential consequences. The Earth's core has long been a subject of intrigue. Discovered in 1936 by Danish seismologist Inge Lehmann, the inner core is a dense, solid metal ball floating within the molten outer core. Unlike the rest of the planet, it rotates at its own pace, sometimes faster, sometimes slower. But how? Do scientists study something buried nearly 5,200 kilometers, 3,200 miles, beneath the surface? Since we can't drill down to the core, researchers rely on seismic waves generated by earthquakes. These waves travel through the Earth and reveal hidden details about its interior. By comparing how similar waves behave over time, scientists can detect changes in the core's movement. And now, they have discovered something surprising. The inner core is composed primarily of iron and nickel and exists at extreme temperatures, over 5,400 degrees Celsius, 9,800 degrees Fahrenheit, comparable to the surface of the sun. It is encased by a swirling ocean of molten metal that makes up the outer core. This liquid layer is crucial because it drives Earth's magnetic field, shielding us from harmful solar radiation. The movement of the inner core is not random. It is influenced by multiple forces acting in different directions. The Earth's magnetic field exerts a force on the core, encouraging it to spin, while gravitational forces from the mantle and outer core pull it in different directions, leading to subtle variations in its motion over time. These forces interact in a delicate balance, creating a complex dance that scientists have been striving to decode for decades. The first real breakthrough in understanding the inner core's motion came in the 1990s, when seismic data suggested that it was spinning slightly faster than the Earth's surface. This phenomenon, known as superrotation, fascinated researchers as it indicated that the core was behaving almost like a separate planet within Earth. However, more recent studies, including the latest findings, suggest that this pattern has changed dramatically. Understanding the movement of the inner core is more than just an academic exercise. This spinning mass of metal may play a crucial role in regulating the Earth's deep interior processes, affecting everything from the generation of the magnetic field to the subtle shifts in the planet's rotational speed. Tracking these movements gives scientists valuable insights into the past, present, and future behavior of our planet. For decades, it was believed that the inner core rotated slightly faster than the Earth's surface. However, a 2023 study proposed a new idea. The core had slowed to match the planet's rotation and was even beginning to move in reverse relative to the surrounding layers. A groundbreaking study published in June 2024 has now confirmed this trend, showing that the core follows a 70-year cycle of speeding up and slowing down. John Vidal, a geophysicist at the University of Southern California, explains that this cycle is influenced by competing forces. The Earth's magnetic field pulls the core, encouraging it to spin, while gravitational interactions with the mantle and outer core create resistance. The result? A delicate balance that leads to periodic shifts in rotation. One of the biggest questions is whether the core's changing motion impacts life on the surface. Scientists speculate that it might subtly influence three key factors: the length of a day. The slowing core affects the movement of the surrounding layers, which in turn slightly alters the speed of the Earth's rotation. However, these changes amount to only a fraction of a millisecond per day, barely noticeable for humans, but significant for precision timekeeping. The Earth's magnetic field. The swirling liquid metal of the outer core generates the planet's magnetic shield, which protects us from harmful solar radiation. If the core's motion changes, it could influence this magnetic field. Some scientists believe this might contribute to minor fluctuations, though no drastic effects have been observed yet. Seismic activity and geophysics, while not directly linked to earthquakes or volcanic eruptions, variations in the core's movement might affect heat flow and mantle dynamics. In the long term, understanding this process could improve predictions about Earth's deep interior activity. To track the core's motion, researchers examined 121 earthquakes that occurred between 1991 and 2023. These earthquakes, centered near the South Sandwich Islands in the Atlantic Ocean, provided a unique opportunity to study seismic waves traveling through the Earth's core at different times. Additionally, they analyzed shock waves from Soviet nuclear tests conducted in the early 1970s. By comparing these datasets, scientists confirmed that the core follows a cycle where it speeds up, slows down, and reverses direction roughly every 70 years. Vidale and his team predict that within the next 5–10 years, the core will begin accelerating again, continuing its oscillating pattern. However, the exact reasons for these variations remain an open question. While this discovery answers some long-standing questions, it raises many more. For example, why does the core have different rotation speeds when moving forward versus backward? Could its internal structure be more complex than we thought? Some scientists suggest that the core may not be entirely solid, but could have pockets of semi-molten metal, altering how it responds to gravitational and magnetic forces. Others speculate that interactions at the boundary between the inner and outer core could play a more significant role than previously understood. Future research will rely on improved seismic data, interdisciplinary approaches, and perhaps even new technologies that allow us to probe deeper into the Earth's mysteries. For the average person, these changes have virtually no noticeable effect. While the core's slowdown may technically shorten our days by a fraction of a second, this isn't something that will disrupt daily life. Similarly, while it might contribute to slight variations in the Earth's magnetic field, there's no immediate threat to our planet's stability. However, from a scientific standpoint, these findings are monumental. They improve our understanding of Earth's deep interior, helping geophysicists refine models of planetary behavior. This knowledge could even have implications for studying other celestial bodies, like Mars, which has a mysteriously weak magnetic field. Furthermore, tracking the core's movements could provide long-term insights into the evolution of Earth's geodynamics. Scientists speculate that shifts in the core's rotation might be linked to larger planetary cycles that span thousands or even millions of years. If we can understand these patterns better, we may one day predict changes that could have broader consequences for Earth's climate and geological activity. Although there is no immediate cause for concern, the continued study of the core's behavior will be crucial for our long-term understanding of the planet. The more we learn about the inner workings of Earth, the better we can prepare for any potential changes in the future. The Earth's core is a mysterious, ever-changing entity hidden deep within our planet. This latest discovery confirms that its motion isn't constant. It follows a decades-long cycle of acceleration and deceleration. While this may not impact our daily lives, it deepens our understanding of the forces shaping our world. What do you think about this discovery? Could it have larger implications that we haven't uncovered yet? Let us know your thoughts in the comments below. And if you enjoyed this breakdown, don't forget to like, subscribe, and hit the notification bell for more fascinating science updates. See you in the next video.